Hello, we are working on assignment 8.2 again, and this time we're going to be working with problem number 15. And here we have a knee right there, which will be our pivot point, and we have the muscle being attached at 25 degrees to the leg. And then the leg is at 40 degrees from the vertical. And we are asked to find the tension in the muscle. So first thing we're going to do is we're going to find the perpendicular force to our lever arm here. And so when I say the perpendicular forces, I mean the perpendicular force of the 33 Newton component for the weight of the leg, and the perpendicular component, which will go right here, for the weight of the foot. So we're going to find these components right here. And then after we find those components, we are going to use static equilibrium to find the vertical component of the tension. So we're going to find that one. And as we go through here, after we find the perpendicular component of the tension in the muscle, we're going to use that to find the actual tension in the muscle by using the sine function. So if we look here to find the perpendicular component of the weight, we would take the weight times sine 40, which would give us 33 newtons times sine 40 gives 21.2 newtons. For the perpendicular component of the weight of the foot, we would take the weight which was given to me in my problem was 14.1 newtons times the sine of 40, and we end up with 9.06 newtons. Now, when we go to find the perpendicular component of the tension, we're going to use our static equilibrium, torque equilibrium equation, or rotational equilibrium. And so then the sum of all these torques, and there's three of them, there's the tension in the muscle, the weight of the leg, and the weight of the foot. The tension in the muscle is going to cause counterclockwise torque, so this one is positive. The tension in the weight of the leg is causing clockwise torque, so that will be a negative. And the tension or the torque of the foot is the same thing. It is causing clockwise rotation, so it's also negative. So now we have an equation, 0 equals all the sum of these three torques. I'm going to add this to both sides of the equation. I end up with 0.2 perpendicular tension equals 19.7 newtons, and then divide both sides by 0.26, and I get 98.3 newtons. Now that's the perpendicular component of the tension of the muscle. So to get our final answer, we need to take and use our sine function, and the sine is going to equal opposite over hypotenuse, or the perpendicular component over the tension of the muscle. And so rearranging that, we get 98.3 newtons divided by sine 25, which gives us 233 newtons. I hope this was helpful.